Here we're going to look at choosing a method of solving in terms of systems of equations and whether we should be using substitution or elimination. Now, the previous couple of videos we've been talking about elimination. This is from the elimination section. But looking at part A, what I notice is that I have a variable already isolated in terms of y. So anytime a variable is isolated, I would usually recommend using substitution, because I can take that y value, or that expression in this case of x plus 13, plug it in and solve for x. So for this specific problem, I would be looking at 2x plus 7 times the quantity x plus 13, and that would be equal to 10. So we do some distribution. Two x plus 7x combine like terms, 9x plus 91 equals 10. I'm going to subtract 91, and we get 9x equals negative 81. Divide by 9, and x will be equal to negative 9. Now, not overly difficult. We should be pretty confident and pretty efficient for solving some type of equation like that. But notice how to start that problem, substitution was probably the best method. It wasn't set up in a standard form, so using elimination probably would not be that practical. I know what x is, so I'm going to go back to my original equation of y equals x plus 13, and I'm going to substitute my x value in, so negative 9, and I would solve for y, which in this case will just be 4. So I have an answer of negative 9, 4. And we're done with the problem. So part A, I would recommend using substitution. Now, could you use elimination? Sure. But for that first equation, you would have had to move x over. So I would recommend just going with substitution for part A. In part B is a little bit different. It's set up like an elimination problem. However, if I add or subtract, I cannot eliminate anything. So what I'm going to need to do is create an equivalent system by multiplying the two equations by a specific number. And again, you could use substitution. Any system you can try to use substitution or elimination. It's just a matter of setting it up in the form that you really want it to be in. But for this problem, I am going to use elimination, and I'm going to eliminate the y values because they are slightly smaller numbers. So I'm going to take this 4 here. You could multiply by negative 4. I'm just going to use 4. So get 32x minus 8y is equal to negative 32. And equation 2, I'm going to multiply by 2, right, this number here. So you get 10x minus 8y equals 34. Okay, you want to be very careful with this problem. We are going to subtract because my y values are the same, but I have negatives, so I need to be cautious. So 32 minus 10x, that will be 22x. Negative 8 minus negative 8 is the same as negative 8 plus 8, so that gets eliminated. And I have negative 32 minus 34. So again, just be careful with your signs. You get negative 66. Divide by 22, and x would be equal to negative 3. Now, again, you could have used substitution here by isolating an x or y value. Y would have been easier in this case, but then you would have to substitute, solve, and do a little bit more work. This problem is probably a bit easier if you just use elimination. So let's finish up the problem. I'm going to take the second equation. I'm going to take 5 and substitute negative 3. and solve for y. So just this series of undoing operations. And we now have our y value of -8. So my final answer will be -3, -8. Remember, it's perfectly okay to just box in the x and the y. I tend to write my solutions as coordinate points because I like to think of these as on graphs, and I'm looking for their intersection point. All right, that's it for this one. Let's just write that we used elimination. The important takeaway is that for any system, you can use substitution. For any system, you can use elimination. Just there's going to be certain systems of equations that substitution is more favorable, and certain ones where elimination is more favorable. Be proficient in both methods. You do want to be able to use both of them, but if you do have a preferred one, just make sure you become exceptionally good at that specific method. All right, that's it for this section.